theory of gases, so we can learn it independently. Like for example, I cannot teach you thermodynamics until I taught you thermal properties of matter. I cannot teach you KTG until I taught you thermodynamics. They have relationship. Like from thermal properties of matter till KTG, it is related chapters. But suddenly oscillations and waves are independent. Now once again, I cannot teach you waves if I don't teach you oscillation. So I am starting today with oscillations chapter, where we are going to learn about three main things. This chapter, if I tell it, is having three different parts. One part, you are going to learn about the basics. That is, you are going to learn about what is the meaning of simple harmonic motion, how it is different from periodic motion or oscillatory motion, what is the relation between them. We are going to learn about the equations of displacement, velocity and acceleration for a uniform circular motion, and how uniform circular motion becomes simple harmonic in nature. We are going to learn about springs, their motion on a fixed axis, and we are going to learn about pendulums, simple pendulum, what is their time period, how time period is found, and what is their time period of oscillation and all these things. Second pendulum and numericals based upon that. So today's class we are going to learn about, if time permits, if we are able to finish this topic, then we are going to learn about all these things as I said you, the basics, the springs and the pendulum. That's all this chapter is all about. A small chapter, fine. So let us start this chapter and go into the subject, and the first thing that I am going to ask you is, what is the meaning of the word periodic motion? Sanjeet, what is periodic motion? Unmute yourself fast. What is a periodic motion? Yes.
A motion which goes constant.
A motion which goes constant is called as Sanjeet. Are you in your consciousness? What is the meaning of motion which goes constant? Think and say. Anshul, what is a periodic motion?
Motion which occurs in a.
Come again?
A motion which occurs
In a fixed amount of time.
Specific interval.
Okay. What about your understanding? Yuvan Shankar, what will you say about a periodic motion? Yes, Yuvan. Whatever you know, you say. It's not about right or wrong. What is a periodic motion, Yuvan?
Motion in specific interval of time.
Okay. Shweta? That's Shweta, online Shweta. What is periodic motion as per you?
Motion for a time period.
For a given time period. Can you give me an example, Shweta? Any example of periodic motion? Any example?
The Earth rotating around the sun.
Earth rotating around the sun, very good. Now this Shweta, offline Shweta, what is another example of periodic motion? Any example? There are numerous. The clock, the hands of the clock. Okay. Yes, Mr. Abhinand.
Pendulum, sir.
Pendulum, good. Yes, any other example? Kirti, you want to add any example? Apart from these examples that I have told? Yes, please. Be a little louder, sorry.
Sir, I am going to say pendulum.
Okay. Somebody else has said, so you don't have anything else to say? Think and say, no, something periodic. There are so many things that are periodic. So many things are there. Think for a while. Somebody has told Earth moving around the sun. Still moon around the Earth is remaining, isn't it? Now don't say Jupiter around the sun, Mars around the sun, moon around the sun, moon around the Earth. Apart from that, okay. Yes, anybody else who has some other example?
Sir, can we say clock as periodic motion?
Somebody said clock already. Clock is,
Okay.
yes, hands of a clock. And yes, Sharan Ram, you are saying something?
Sir, fan.
No, sir.
No, okay, yeah. Sai Rakshana, please tell. Good.
Fan, sir.
Fan, good example. So fan is periodic as per Sai Rakshana. I'll talk about that. Anybody else? Anything else you have in your mind, or shall I start speaking? Any other example of periodic motion? So as somebody said, and it is true, periodic motion are those which repeats itself in certain interval of time. If you consider Earth moving around the sun, every 1 year it completes one round. 365 days, every 365 days you will be able to see that Earth is taking one round of the sun, isn't it? If you talk about This person, can we say he is in periodic motion? Obviously, he is in periodic motion because it is computerized. In reality, we cannot make it periodic, but it is made by animation, so it is periodic. Periodic motion is all about motion being, it is repeating itself in a fixed amount of time. You know one thing, if I walk like this, again walk like this, again walk like this, and if I make sure that the time I take to come across your screen is always some 2 seconds or 3 seconds, then I can also be called to be in periodic motion. Am I right? Periodic motion is anything, any motion which is repeating itself in certain interval of time, like somebody said, hands of a clock, minute hand, hour hand, second hand, all the hands. Every hand is completing one full round of this circle in a fixed amount of time, isn't it? Second hand takes 60 seconds to complete one round, am I right? Minute hand takes how much? 60 minutes. And hour hand take how much? Huh? 12 hours. Somebody should not say 24 hours. 24 we are thinking inside. I am talking about 3 hands, second, minute and hour. Second hand takes how much time? 60 seconds. Minute hand takes how much time? 60 minutes. Hour hand take how much time? 12 hours.
12 hours.
Yes. So these are the motions which are obviously periodic because it is repeating itself in certain interval of time. What about this? Don't you think it is periodic? This spring which is having a mass, practically also we can make for some time, not for always. So if you think this spring is going up, down, and if this spring is taking equal amount of time or same amount of time always to come down and go up, this spring also can be called to be in periodic motion. I hope you are understanding. What about this girl who is sitting on a swing and enjoying the day? It's pendulum. Like a pendulum, but it's not a pendulum. It's a swing. Okay, I'm not saying that it is not similar to pendulum. It's similar to, does it look like pendulum to you? It's a human being here, girl sitting on the swing. Okay, pendulum is not a living thing, isn't it? Yeah, bob and a string. So it is like a pendulum, I accept, but it is a girl who is swinging on a swing. She can also be called to be in periodic motion if she maintains equal time to go front and come back. When she starts her motion, it's not periodic. When she stops her motion, it cannot be periodic. But while she was moving for certain period of time, it can be periodic. Same happens for the fan Rakshana. For the fan, when you start the fan, it is not periodic. When you stop the fan, it is not periodic. But for a certain amount of time when the fan starts to run, it becomes periodic. Am I right? Because for periodic motion, it should repeat itself in certain interval of time. The time should not change. Initially, it will be slowly starting, isn't it? And when it starts to move with the full velocity, then it takes its constant speed. Once again, when you increase the speed, its velocity will change. So periodic motion is only for a fixed amount of time when it is moving in a particular time interval. So then comes the definition of periodic motion. All of you can write it. The motion that repeats itself after regular intervals of time is said to be periodic motion. Definition of periodic motion is the motion that repeats itself after regular intervals of time. Like how I said, now this is periodic, man. This is not a human being. This is a periodic motion literally, where a bob is attached to a string and it is moving to, fro, isn't it? It's a periodic motion, obviously, no doubt in that. And the examples you can write by yourself. The examples of periodic motion can be pendulum, earth around the sun, moon around the earth, or whatever I told in some time back. Anything you can write as the examples of which motion? Periodic motion. So all these examples, spring you can write, swinging of girl you can write, pendulum you can write, that party sitting on the chair and going front and back you can write, this clock you can write, this planet moving around the sun you can write, or this gentleman, I think he is doing shot put, isn't it? Looks like shot put to me. Not shot put. What is that then? Some kind of dance. Hammer throw, okay, whatever. Yes, shot put is by hand, sorry. So hammer throw. So that kind of some kind of sport. So he is also trying to be in periodic motion. In reality, we cannot be really in periodic motion for doing this. For a few seconds, we may come. So I hope it is clear what is the meaning of periodic motion. Not new for you. Yes, just tell me. Yeah.
So it need not maintain the same speed, right?
It is not to maintain the. If it is not maintaining the same speed, then how it will cover the same distance in same time? Isn't it? So obviously it will have same speed. If it is varying speed, it will take less time to cover, no? Or more time to cover, no? If it goes more fastly, then it will take the same time you are thinking. No, less time it will take. If it is going slowly, it will take more time. So then it will not remain periodic. Yes. For periodic, obviously velocity should be same at any instant. It should be. Okay? I hope it is clear to you. Very basic thing I am talking. This we are learning in small classes also. Rectilinear motion, periodic motion, isn't it? In our 8th standard or 7th standard, we learned about this motion chapter. Okay. Now coming to this topic, which is oscillatory motion. Now oscillatory motion, what is that? How it is different from periodic motion? Can anybody tell me what is the oscillatory motion? Sitting here, before I go to the online people. Varshika, what is oscillatory motion? Say, what you know you say. I am not going to do anything. Yeah, please. This much time you should not take. Instant answer should come.
Time taken by an object to cover one oscillation.
That is oscillation motion, or oscillatory motion. You should not use the word oscillation when you are speaking about this. Yes.
Like pendulum it oscillates. It comes
Okay.
to the original position without completing complete circle.
Oh.
Just thinking.
Oh, good, very good. Yes, I'll give chance to Pratap now.
Oscillating motion is the type of a periodic motion where the object moves to and fro.
Okay, Deepa, I think the same thing you also thought of saying. Deepa Jyoti. Where is she?
Yes,
Same. That was okay. And they are right. See, oscillatory motion is a kind of periodic motion in which the object moves to and fro. All the oscillatory motions will definitely be periodic, but all the periodic motion will not be oscillatory. Like movement of earth around the sun is periodic. Is it oscillatory? No, it will not come back, right? It goes only in one particular direction. The movement of hands of a clock is periodic, but is it oscillatory? No. That girl sitting in the swing is oscillatory. To, fro. The spring moving up and down is oscillatory. To, fro. The pendulum on the bob is periodic and oscillatory. To, fro. Granny also is oscillatory, obviously. She was sitting on a, I don't know what you call that chair as, and doing front back, oscillatory. So oscillation is a type of periodic motion where the object is moving to and fro. Simple? Okay, now I'll ask you, what is vibration then? Vibration?
That's also like oscillation, but
Okay.
it's very fast.
Very fast. Good, very good. That is the definition of vibration. Vibrations are quick oscillations. Are you getting? Now I will say vibrations are type of oscillatory motion which are fast. So all the vibrations are oscillatory, but all the oscillatory motions are not vibration. Are you getting the hierarchy? First is periodic, then is oscillatory, then is vibration. Vibration motion will definitely be oscillatory, will definitely be periodic, isn't it? All the oscillatory motion will definitely be periodic, and all the periodic motion will not be oscillatory or will not be vibrational. I hope it is clear to you. So definition of oscillatory is to and fro motion of the object about its mean position. That is the definition of oscillatory motion. And there itself you can write below, quick oscillations are known as vibrations. Quick oscillations are known as vibration. Manoranjan, shall I put you in the waiting room for not on in the camera? Your camera should be always on, Manoranjan, please. Yeah. So you please write this definition of oscillation, and you can write a line below, quick oscillations are known as vibration. So in regular school curriculum we call this chapter as oscillation. If I talk in competitive class, no, I will not call this chapter as oscillation itself. It has a different name. The chapter name is SHM, simple harmonic motion. In competitive section, this like how in competitive section we call system of particles chapter as rotational mechanics, same way in competitive section, in if you see NEET and JEE books, then they will usually they will write this chapter name as SHM, simple harmonic motion. Now we learnt about periodic, we learnt about oscillatory, we learnt about vibration. What is this SHM, which is simple harmonic motion? We will talk about that now. So, some of you, if you want to write the difference between oscillatory motion and periodic motion, please note it down, because in exam it may come for 1 mark or 2 mark. Difference between oscillatory motion and periodic motion. Take 1 minute of time and please copy it. Take 1 minute of time and please copy this difference between oscillatory motion and periodic motion. So, in oscillatory the body moves around a mean position, definitely. In periodic it is not like that. And in oscillatory motion at extreme the velocity is 0, and in periodic velocity is never 0, obviously yes. And in oscillatory the direction gets reversed at extreme points, and here the direction never reverses, it will always be in same direction, isn't it, periodic motion? Yes.
I can't understand.
I will tell you, man, Sugendran. I am writing the difference between oscillatory motion and periodic motion, okay. So, the first difference is oscillatory motion, the body moves about a mean position. Like if you see this diagram, it is moving around a mean position, right, Sugendran? Mean is the center position, it goes to fro. You be unmuted for some time, Sugendran, unmute yourself for a few seconds. Yeah. So, this is called as oscillatory motion, right. But if you look at this diagram, this is a periodic motion. Which one? The earth moving around the sun. Or you talk about this hands of clock. When they are moving, they are not moving around any mean position, it keeps on moving, right. But if you see this, it is this pendulum or this girl or that party, all are moving around a mean position, to, fro, to, fro, to, fro. Are you getting? So, they are in oscillation, she is in oscillation, pendulum is in oscillation, this girl wearing black dress is in oscillation, this particular spring also is in oscillation, but these two are periodic motion but not oscillatory motion. Are you understanding, Sugendran?
Yes, sir.
So,
Yes, sir.
these things only are mentioned in that difference table. If you see the table, then they have mentioned that in oscillatory motion it moves about a mean position, whereas in periodic but not oscillatory it is not moving around the mean position. Oscillatory motion at extreme position velocity is 0, obviously it has to be 0, because when it becomes 0 only it will come back, isn't it, Sugendran?
Yes, sir.
Yes.
Sir.
So, it will go like this, become 0 and come back. So, at extreme position velocity becomes 0. In the case of periodic motion, velocity can never become 0. Can Earth's velocity become 0? Never, right? It keeps on moving, right. Third difference is, if you see direction, this bob in the pendulum was going towards right, became 0, then comes towards left, becomes 0, goes towards right, becomes 0, goes towards left. Am I right? So, left, right, left, right, left, right. But in oscillation, that is periodic motion which is not oscillatory, it is keep on moving only in one direction, isn't it? It is not changing like left, right or clockwise, anti-clockwise. It remains in the same direction. That is what they have mentioned. Direction of velocity never reverses itself in the case of periodic but not oscillatory motion. Understanding, Sugendran?
Yes, sir. I understand.
Okay. So, I hope you have copied this difference. If not, Sugendran, you can take a screenshot and copy later, because I was talking to you, or I will share the video to you, you can copy from there later. Okay. Can I proceed further?
Yes, sir. Thank you.
Can I proceed further?
Yes.
Okay. So, now first before I enter into the circular motion, let us talk about some basic terms. In this chapter we will be using very frequently time period, frequency, displacement. What are these things? What is the time period? When I say time period, what is the meaning of time period? First you write this, the smallest interval of time after which the motion is repeated is called as time period. Smallest interval of time after which the motion is repeated. The smallest interval of time after which the motion is repeated is known as what? Time period. So what will be its unit? Obviously seconds, time will be in seconds. And example they have told, like if you see a minute hand, what will be its time period in seconds? Minute hand takes 60 minutes, isn't it? 60 minutes means 16 to 60 how much? 3600 seconds. If I ask you what is the time period of a second hand, what will be your answer? 60 seconds. If I ask you for an hour hand, 12 into 60 into 60, whatever it comes, I think 8 4 something it will come. That is the time period of hour hand. So whoever's time period you want to find, you need to find that how much time it takes to complete one full oscillation, isn't it? So time period is the time taken to repeat itself, that is complete one full oscillation or full periodic motion. So in this case, as I said you about the thing, Earth's revolution, what is the time period? 1 year, obviously, common sense. Okay, what is frequency? Frequency is number of oscillations per unit time, right? Frequency is defined as number of oscillations per unit time. These are very basic things, you know it from your childhood itself, but still I am recalling it. Very soon I am going to enter into the 11th level of this chapter. So as of now you can write frequency is number of vibrations or number of oscillations per unit time. Number of oscillations per unit time. And what will be its unit? Frequency is always in hertz. 1 by t, 1 by second, or second inverse, also called as hertz. Second inverse, also called as hertz. And obviously it is reciprocal of time period. So frequency is equal to 1 by t, isn't it? Frequency is reciprocal of time period, and since time period of the minute hand was 3600 seconds, if I ask you what is the frequency of minute hand, what will be the answer? Frequency of minute hand will be 1 by 3600 per second, or you can also call it as hertz, isn't it? This much you can also call it as hertz. I hope you are understanding, isn't it? Also at this point of time, I would like to talk to you about angular frequency also. Like how we told frequency, we have something called as angular frequency, which you studied in 2 chapters. You studied about this topic in motion in plane, studied about this topic in rotational mechanics also. I will come to you once again, where angular velocity is omega, isn't it? Same angular velocity is angular frequency. Omega we can call angular frequency also, we can call angular velocity also. And angular frequency omega is always equal to 2 pi by time period. See, it is very simple. Frequency is 1 by time period, isn't it? Frequency was time taken to complete one oscillation or one vibration, whatever. So it starts from here, it takes how much time? That is frequency or number of oscillations per unit time. On the other hand, if I write about angular frequency, it is in terms of angle, isn't it? So in this time period, how much angle it covers? 2 pi. That's why it is 2 pi by t. Are you getting my point? So from here only we get the formula, time period is also equal to 2 pi by omega. It will be used in many places in this chapter. Time period is 2 pi by omega, or omega is 2 pi by t. Both are related. Is it clear? Very basic things we are talking. Still we have not entered the main part of this chapter. Yes, I am waiting. Make it fast. Please, written. Shall I proceed further? Okay. Now, a simple question. A simple question. Tell me the answer fast. A human heart beats at around 72 times in a minute. Calculate its time period and frequency. Obviously. Frequency you can find, reciprocate it, that will be time period. Any answer?
6 by 5, yes, sir.
6 by 5, what hertz?
Yes, sir.
6 by 5 is the frequency.
1.2, yeah.
5 by 6 hertz.
5 by 6 is the answer by Shweta. And 6 by 5 is the answer by Sai Akhilesh. What do you say? 6 by 5. So you are supporting Sai Akhilesh.
That's 6 by 5.
6 by 5 is Niranjan's answer also.
More than 60, so it should be more than 1.
Shweta, think once again here. It takes 72 times in 1 minute. How can it be less than 1? It should be more than 1 only, no? (72 by 60), how can it be less than 1? Are you getting my point, Shweta? She disappeared.
Time period can be 5 by 6.
Huh? Time period? Obviously it will be 5 by 6. I think now she will say I told time period only. Okay. So frequency is 6 by 5, obviously right, 1.2, and the frequency, that is time period, will be reciprocal of that, which will be 60 by 72. That will become equal to 0.833 seconds. Very basic 1 mark question.
So every 0.83 seconds the heart beats.
Obviously. So heart beats at every 0.833 second, less than 1 second. Isn't it? Biology students. Shall I proceed further? Shall I proceed? Simple question it was. Does not deserve. And what is displacement? It is the change in position under certain time. So once again, displacement is much known to you from first chapter itself, and angular displacement also is known to you from which chapter? From motion in plane, isn't it? So angular displacement, I told you that suppose if there is an object which is moving in circular path, then how much angle it traverses, this angle was called as what? Angular displacement. You remember? This is angular displacement and this will be linear displacement, isn't it? I hope you remember this. So displacement is change in position and angular displacement is change in angle. If it is moving in some oscillation or in circular motion, what is the change in its angular position is called as angular displacement, theta. And theta will become equal to how much? Can I say theta is equal to omega t? Obviously, angular velocity multiplied by time will give you angular displacement. Again, much used relation, theta is equal to omega t will be used in many places today in the chapter. Remember this, theta is equal to omega t. What is that? Angular displacement is equal to angular velocity into time. Very simple, isn't it? I hope you are understanding. So, let me go into the, like here I have shown you angular displacement, here I have shown you linear displacement. In the case of spring, the spring is undergoing linear displacement, whereas the pendulum is undergoing angular displacement. So in this chapter we are going to talk about both. In some place we will talk about angular displacement, in some place we will talk about linear displacement. Okay. With all this basic knowledge about this chapter to you, now we are going to start the first, before that, the one more thing is remaining. I have still not explained you what is the meaning of simple harmonic motion, isn't it? I told you what is periodic motion, I told you what is oscillatory motion, I told you what is vibration motion. Now we should understand what is the meaning of simple harmonic motion. Looks like some complex term, but it's simple, don't worry about it. Okay? So let us understand what is the meaning of simple harmonic motion. If you see this object, that is a mass attached to a spring, and this mass, if I have pulled it towards right and left it, what will happen? By itself, it goes in the back direction, right? It does not stop here, it overshoots, compress the spring and go towards left. Once again, when its velocity becomes 0, it stops, but now it will have its potential energy, elastic potential energy. Once again it will come back. It won't stop in the mean position, it will overshoot. If we consider the case to be frictionless surface, then it will keep on oscillating forever, theoretically. Practically, loss of energy will be there, friction will be there, it will stop in some time. But theoretically, if it is a frictionless surface and there is no loss of energy, it can keep on oscillating, right? If you see this kind of motion, you will notice that there are 3 things. First thing is, I can represent this motion by a sine wave or a cos wave. That is, I can write y is equal to some a sin omega t or y is equal to a cos omega t. I can write like that. If you wonder how, today I will teach you. So first condition for any periodic motion to be simple harmonic is that it must be represented by harmonic functions. Now, what is the meaning of harmonic function? Sine function, cos function are called as harmonic function. So, if a particular motion is represented by harmonic function and its acceleration is always directed towards a fixed point or towards the mean position. If you see, if I move it towards right, it tries to come towards mean. Even if it goes towards left, it once again tries to come towards mean. So, always the acceleration is trying to bring it back to the mean position. I hope you are understanding it. I will repeat, Sugindran, I hope you are there. So, if I have a bob and if I move the bob like this in some height and leave it, what happens? Bob starts moving. Will it stop in mean position? No, it will overshoot. But even if it is overshooting, it goes to some height and tries to come back to the mean position only. Once again goes to some height, tries to come back to the mean position only. And finally, it will try to stop in the mean position only. Isn't it? Same with the spring also. If I pull and leave, it goes to fro. It tries to come back to its mean position only. I hope you are understanding this. So, this is the second condition for the SHM. Second condition is direction of acceleration should always be towards the mean position. And third condition is that magnitude of the acceleration must be proportional to the distance from the fixed point. Obviously, yes, it means that if I displace more, it should have more acceleration. If I displace less, it should have less acceleration. Are you getting my point? So, there are three things here. If they ask you which motions are called as simple harmonic motions, there are 3 points for it. The first point is it must be represented by a harmonic function. Second point is the direction of acceleration should always be towards mean position. Third point is the acceleration must be proportional to the distance from the mean position. That is, if you displace more, it should have more acceleration. If you displace less, it should have less acceleration. Is it clear to you? So, which oscillatory motions will be coming under SHM category? All the oscillatory motion which follow these rules. Once again I am repeating, all the oscillatory motion may not be simple harmonic. Only if they are following these 3 rules, then we are going to call them as simple harmonic motion. So, you should be very clear in that. First is it should be represented by a sine wave or cos wave only. It must be directed towards a fixed point. That is, so I can say this point. The second point I can say that the acceleration must be proportional to minus y. Can I say like this? Why I am saying minus y? Its direction should be opposite to where you are displacing it. If you are displacing towards right, action should act towards left. If you are displacing towards left, acceleration should try to once again bring it towards right. So, I am writing acceleration is always proportional to, if I am writing y, it proves by this point, because acceleration should be proportional to the distance from the fixed point. And if I am putting a negative sign in front of it, it is satisfying the second criteria, isn't it? So, A is proportional to minus y, satisfy which criteria? Second criteria also and third criteria also. And the first criteria is the equation of the motion y must be equal to A sin omega t or A cos omega t. If your motion is represented by this harmonic functions, only then it comes under the category of simple harmonic motion. Is it clear to you? 3 things are clear: harmonic function, acceleration proportional to displacement, and acceleration should have opposite direction of displacement. Anybody has any doubt? Ask me. If no doubt, I will proceed further, because with this knowledge only you should start talking about the circular motion. Shall I? Ivan went for tea break. Mr. Ivan Rufus, there in the class or not?
Yes, sir.
Don't off the video here and there. Please be in the class, because I will feel like you have gone for some other activities when you are offing the camera. Don't touch the camera when the class goes on. Shall I proceed further? Shall I proceed further, guys? If you allow me.
Yes, sir.
Yes.
Yes, sir.
Now we are going to enter into one of the very interesting topic, and it is very simple, and for school exam point of view, it is a 5-mark question. Check your school exam, that is going to happen. In school exam, they will ask you derive the equation of velocity, acceleration, energy, displacement and all these things. And it is very simple, need not to mug up anything. If you are understanding what I am going to teach you now another half an hour, then you will be clear in this 5-mark question. In question like mark wise, if your aim is to get good marks in exam, then this topic is very important. And obviously, to understand SHM properly, this topic is very important. In competitive examinations also, question comes from this topic. If you are preparing for NEET or JEE, then definitely this topic is very damn important for you. And interesting also if you are focused in the class. Until you start thinking about something else, you should be having the interest. Okay. Now, circular motion is not new for you. We have talked about circular motion in the second, third chapter itself, motion in plane itself, where when an object starts moving in circular path, centripetal force acts towards the center of it, isn't it? All these things we have studied in our earlier chapters itself. But now, if I talk about like this thing, it is moving in which path? Circular path. You may think how the circular motion is becoming oscillatory. It is not oscillatory itself. Where is the question of SHM? You may think that if an object is moving in circular path, very clearly visible to you, it is not having to and fro path. Is it having to and fro path? No, right? How it is going? Circular motion. It is a periodic motion. All of you will accept. If I ask you whether it is circular whether it is oscillatory motion, immediately you will say no. Obviously no. Anybody can say it is a oscillatory motion? Nobody can say. Fine. I agree with you. I agree with you. But see how twist will take place now. Have you ever seen a person who comes to sharpen the knife? Sai Rakshana, Joel, please, there. I don't want you put in the waiting room. Don't make me to waste 2 3 minutes of time to say on your camera. Camera should be on only. Yes. Have you ever seen the person who comes to sharpen the knife? He moves in the street, right? Have you ever went and sharpened the knife with him? Not got a chance.
Yes, sir.
Okay, you have done. I have done recently also. Cycle pedal will be there, and there will be a wheel, and in the wheel he will touch the knife, spark will come, it will become sharp. Have you seen that? Looks interesting when he does that.
Stone cutter, right?
Yeah, stone cutter only, a metallic cutter, whatever it may be. Stone cutter only generally it will be. A stone wheel will be there. But have you ever seen that when he starts moving the wheel in the circular motion, he does that by having a pedal for it, and pedal he will move up, down, up, down, up, down. Have you noticed it? If not, future you notice.
Yes, sir.
Hereafter, whenever you see some knife sharpening guy on the road, intentionally take one knife from your own and ask him to do it, or see somebody else doing it. You will realize that that person who is sharpening the knife is pedaling up, down, up, down, up, down, and the wheel is moving in circular motion. There is a relationship between oscillatory motion and circular motion. So, if you see carefully, you will realize that when an object is undergoing circular motion, the black point in this diagram, the black dot is undergoing which motion? Circular motion. See the blue dot? Oscillatory motion, right? So, when this particle is undergoing circular motion, this particle, the blue particle, is undergoing oscillatory motion. Not only him, not at this point. If I take a point on the x-axis, the same thing happens. So, remember, if one object is undergoing circular motion, the x-axis and the y-axis are undergoing oscillatory motion. Tell me, Mr. Abhinand.
Accelerating and decelerating, accelerating and decelerating.
Obviously, we'll talk about that, what happens. Have you ever seen pendulum clock?
Yes.
I hope you would have not seen the real pendulum clock. I have told this to you, you would have seen this in many places, but in reality, I have seen recently also, in one home I have seen it. It is a heritage thing. See, pendulum clocks should not have any battery first of all. If you have seen a pendulum clock which has a battery, it is a fake pendulum clock, because they are using one battery for running the clock, another battery for running the pendulum. Just for show it is. Real pendulum clock is something like, by the motion of pendulum, They are creating a circular motion. Are you getting? Pendulum will undergo what motion? Oscillatory motion. Hands of the clock will go which motion? Circular motion. That's the real pendulum clock. And real pendulum clock, you know one thing, every day you have to give a key there. The key will once again make the pendulum to go. Do you think pendulum can go by itself to and fro? It is violation of thermodynamics law. It cannot happen, isn't it? So we have to daily get up in the morning and somebody has to go and screw that pendulum, then only pendulum will keep on moving and it will keep on moving the clock. Forget one day, it will stop. I have seen that clock. That is a real pendulum clock, not the one which we have in our home, that plastic one where something will go, but see behind there will be 3-4 batteries. It is show. It is not the real pendulum clock, because
What
real.
if that battery is making it, pushing the pendulum to move to it? That would be the thing, right?
But
Instead of us screwing it manually,
Huh.
the battery is powering it up to move it.
it's waste. Then what is the use of pendulum clock? Why we want pendulum clock? To save the battery only, no man. You are having a battery to run the pendulum. Pendulum is running the clock. For that you buy a clock which has directly battery running the clock. Why you want to have pendulum for that? Are you getting a point? Your point is correct. Sir, I am putting battery, but the battery is running the pendulum. And pendulum is running the clock. Then why do you want to have it, man? Directly use battery for running the clock. Isn't it? Meaningless, no? But real pendulum clocks will not have any batteries. Generally, if you see in some church, old church and all, it will be there, where you will have a big wooden kind of setup. And there will be a glass covering the pendulum. Because if air is there, friction is there, then it will have less time period. So what they will do, they will cover it. A box will be there for having that down thing, pendulum thing. And every day somebody will go and turn the pendulum and come. For that turn, it will keep on oscillating for some time. After some time when the energy gets exhausted, once again somebody has to go and turn. If somebody forgets, it will stop. I hope it is clear to you how a pendulum clock functions. Pendulum clock also functions with the help of uniform circular motion only. Coming back. So what we are going to do, now we are going to consider a particle, right? Here if you see, there is a particle which is moving around a circular path. I am taking that particular particle and I am making it to move in which path? Circular motion, and I will try to derive all the equations of displacement, velocity, acceleration, energy, kinetic energy, potential energy, total energy, and all the graphs. It's continuous topic. Next half an hour you have to be in the class. I mean, obviously physically you are there, mentally also, because it is an important 5-mark question for school examination. And all the results that I am going to get, all the results, very important for competitive examination. So please be focused, don't sleep in between, be focused. Okay, Avinash? I hope you will be. So this object, this particle is moving in circular motion, having an angular velocity of omega. If it happens, then I have written already here, this will become omega t, isn't it? If I take any particle, like if I draw a perpendicular line down and a perpendicular line on y axis, I can say that this point, let this point be anything, you can write a capital Y or you can write here a capital X. The point X and point Y are undergoing oscillatory motion. Do you accept? When this Q is going from here, it is going up, 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 up. This Y from 0 it goes up, 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 up. When the Q comes at this point, then this Y will have the maximum radius, maximum displacement. Let's call it radius or amplitude. We are taking it as capital A here, you see. And once again, when the particle Q starts moving from this position to this position, the Y starts coming down. And when the Q is reaching at this position, the Y becomes 0. Once again, when the Q moves from this point towards down point, the Y starts moving downwards and goes in negative direction, having the maximum negative displacement. And once again, when it moves from this point, let me name these points, no, it will be easy. Let this point be A, let me not use A because A is already used for amplitude. I will use it as B, I will use it as C, D and E. So when the particle is going from E to B, that time once again the displacement is going on reducing once again towards A. So when it moves from B to C to D to E to B, the particle Y, it goes from O, goes above, 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 plus A, 0, minus A, 0, plus A, 0, minus A, 0, plus A, 0, minus A. I hope you are understanding this. right? Same way, x point, if you see, when this particle from Q, that particle Q goes from B to C, then the displacement from maximum it becomes 0. And once again, when it is going from C to D, it becomes 0 to minus A. When it is going from D to E, it is going from minus A to 0, and when it is going from E to B, it is going from 0 to A. So, how it is moving? 0 to plus A, sorry, starts from plus A actually, plus A to 0, 0 to minus A to 0, 0 to plus A, and keep on moving to and fro, to and fro. Are you understanding this? Are you understanding what is happening? Okay. Now, if I take this distance OX as x, small x, and if I take this OY as small y, I will give time for writing. Please pay attention, I will give time for writing. I told you, understand this 5-mark question, exam point of view, an important thing. I will give time for writing. Sugendran, if you had your milk, then please on your camera. So, x is the displacement of the point in x-axis, and y is displacement of point in the y-axis. Okay. See this triangle QOX. I am drawing it here. Triangle QOX. If this is omega t and this will be A, do you agree with me? OQ is the radius, it will be A. Anybody has doubt in this? Okay, if I write what is sine omega t, what will be your answer? Sine omega t will be how much? What by what? OX actually is x and XO is y, isn't it? So it will x by A. Do you agree? Or if I write cos omega t, what will be cos omega t? Ulta you told, right? This was y by A and this will be x by A. So can I write that equation of x will become equal to A cos omega t, or equation of y will become equal to A sin omega t. One of my condition for SHM is satisfied here itself. For any motion to be SHM, the first condition was harmonic function. I got it. I got the function as harmonic because the displacement is either A cos omega t or A sin omega t. Yes, Manoranjan, please ask your doubt.
The capital A represents amplitude.
Obviously amplitude, because amplitude is the maximum displacement, isn't it, Manoranjan? So here if you see from 0 maximum, once again 0, minimum, once again 0, maximum, once again 0, minimum. So A represents the amplitude, yes. Okay, coming back. Now, either I can proceed after this, the equation of velocity, acceleration, energy, everything, by taking y is equal to A sin omega t, or I can proceed by taking x is equal to A cos omega t, completely your wish. Are you getting my point? I can get the velocity in x direction, or I can get the velocity in y direction. It's my wish. Let me take it as y and solve. You can solve by x also. I will give that as a homework today. You can solve all these things by taking x is equal to A cos omega t also. Now I am going to use y is equal to A sin omega t. What is this? Equation of displacement, right? Some more thing I want to tell you. If you talk in terms of omega t, at this point omega t is 0. Do you agree? I will take some other color. Yes, omega t is 0. At this point, what is the omega t value? How much degrees? 0. Omega t, you see, man, angle is becoming 90 degree here. And what is omega t here? Pi, good. What is omega t here?
3 pi by 2.
3 pi by 2, good. And what is omega t here? 0, or it will once again become 2 pi.
2
Can I write like this? So how the angle is changing, your understanding? From 0, pi by 2, pi, 3 pi by 2, 2 pi, once again it will go like this only, keep on going. If I talk in terms of time period, this time period is 0 here, t is equal to 0 here, right? T is what? 0 here, starting point. The whole thing is t is equal to t, isn't it? Time period is time taken to complete one oscillation. If I divide the time also, here time will become capital T is equal to t by 4. Here time will become t is equal to t by 2. Here it will become t is equal to t by 3. Yeah? 3t by 4, no man? 3t by 4, 75%. And here it is t is equal to t. I will repeat. Time period starts from here at 0, t by 4, t by 2, 3t by 4, capital T, full T. Understanding how this time period is moving? Time period, if I want to say at this position, is t by 4. What is the angle? 90 degree. Time period here is half, t by 2. Angle 180. Time period here is 3t by 4. Angle here is 270. Here time is full time t and the angle is 360 degree. Anybody has any doubt, stop me and ask. Sugendran, clear up to here? If
Yes, sir.
any doubt, stop me, because I am going to enter into the velocity equation after this. Is it clear up to here? Fine. Now, please pay attention. The displacement y, if you take this position, which position? Position B or position D? B for ball, D for dog, B and D. Then I can say that displacement is 0, right? Y is 0. It means that is the mean position. This A, the BD line is the mean position line. When the point is C or the point is E, displacement is A or minus A. It is maximum. So can I say it is the extreme position? Whenever I will use the word mean today, you should understand the object is either here or here. Whenever I say the word extreme today, understand the object is either here or here. Same way, if somebody is taking x is equal to a cos omega t, B and D will be extreme, C and E will be mean. I hope you are understanding it, because for x axis it is maximum, it is reducing, becoming 0, then again becoming minus a, becoming 0, and again becoming plus a. I hope you are understanding how displacement changes for x, how displacement changes for y. Clear to you? Saw the dream, Abhinand? Okay, thinking about this only. I thought something else you are thinking. Okay, so at mean means, in this case I am taking y case. So at mean I used, it means when either you can write omega t is 0 or you can write t is equal to 0, isn't it? Both you can write. In this kind of scenario, what will be y? Y will also become equal to 0. How it came, you understand? Because a sine omega t is 0, sine 0 is 0, y became 0. Understanding? I hope you are understanding. Same way, if I write at extreme, what is the meaning of extreme? Extreme is equal to omega t as 90 degree. That is pi by 2 you can write, or you can also write 3 pi by 2. Or I can write capital T as t by 4, or you can write even 3t by 4. So what will be y? Y will become equal to plus or minus a. Do you agree? At y is equal to, that is at omega t is pi by 2, it will be plus a. At omega t as 3 pi by 2, it will be minus a. So the displacement is 0 at the mean position. Displacement is plus or minus a at the extreme position. Is it clear to you? So
Last time y can only be
plus a, minus a.
in that range it will be
It can be anything. So if the amplitude is 5 meter, the displacement can never be more than 5 meter. It can be 5, 4, 3, 2, 1, minus 1, minus 2, minus 3, minus 4, minus 5. Anything between minus 5 and plus 5. What will be the range of displacement? Minus 5 to plus 5. If amplitude is 5. Are you understanding this? I hope it is clear to you. Sure? So you have understood the equation of displacement, and you have understood what is the meaning of mean position, what is the meaning of extreme position, what is the displacement in mean position, and what is the displacement in extreme position. If yes, copy it in 2 minutes, I will go to the next page then. If it is clear, make it fast. Copy whatever you want to copy from the board, and I will go to the next slide where I will go to the velocity equations. Now I have derived only displacement equation. Make it fast, please. Sure, so fine. Make it fast. So, if somebody would have taken x is equal to a cos omega t, then at mean position, what will be the value of x plus or minus a? Extreme position it will be in for this extreme and this mean. X will have its own mean, its own extreme, isn't it? Because in the case of x, I will take b and d as extreme, and I will take c and e as mean. So, when I write omega t as pi by 2, I will use it as mean position, where I have used extreme position here. So, it will remain same, x will become equal to plus or minus a at extreme, x will become 0 at mean, because the mean points will change. I hope you are getting my point. Okay, it will be more clear when I go to the velocity equation. I hope you have copied. Shall I proceed? Shall I go to velocity equation? Varshika?
Yes, sir.
Okay, I will wait for 1 more minute, but not more than that. Please make it fast.
You can also.
Thank you. Here, Varshika written. Fast, 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 please. I think you can write by yourself after this. You don't think you need my support if you have understood. What have Pratika written? Can I proceed? Okay. Shweta Shinde, here and there you are offing your video. I will proceed further. Okay. So, I will go to the next page. Next is about the velocity. Now, when I say velocity, see in this diagram it is representing the x only, but we are doing for y, so it will be the movement in the y axis. So, here if you see, this is what I should have derived if I took x as displacement, but I am taking y, so I am deriving in this particular axis. Okay. Anyhow, the concept remains same, so it hardly matters to us, because we are going to do the derivation by taking y is equal to what? Y is equal to what here? A sin omega t. What will be displacement then? Sorry, what will be velocity then? Velocity is what? Rate of change of displacement, dy by dt. So, you differentiate, what will come? Sin omega t is what? Sin omega t differentiation is what? Okay, sin omega t into omega.
A cos omega t into omega.
So, a omega cos omega t. Can I say like this? Can I say like this? What Abhinand? Sin omega t differentiation is cos omega t, and omega t differentiation is omega. You don't know that rule, chain rule it is called as. Okay. Anyhow, it's not a big thing. If you want, I will teach you separately. Okay, it's very simple basic math differentiation. So, a omega cos omega t is velocity. So, velocity equation you got as a omega cos omega t. Can I write, please pay attention, something important I am doing. Can I write this as velocity is equal to a omega cos a square omega square cos square omega t under root? Can I write like this? Why you are doing that? Good question. I will tell you why. Because I will write root over a square omega square. Instead of writing cos square omega t, I will write 1 minus sin square omega t. Now, why you are doing this? Again a question for you, good. Then I will write V is equal to omega I will take outside, omega square I will take omega outside. What remains inside is root over a square minus a square sine square omega t a. Now tell me, what is a sine omega t? What is a sine omega t? Y. So I will get omega is equal to V is equal to omega into root over a square minus y square. Velocity has this equation also, or it can be written as this equation also. Both we can use, our wish. Easy, I know, but see, this is the equation of velocity in terms of what? In terms of, yes, in terms of omega t. And this is in terms of displacement, isn't it? So we don't know which we want to use in the future. So we are learning both, safe, right? Somewhere you may use V is equal to a omega cos omega t. It will help you in the solving the numerical. Somewhere you may require V is equal to omega into root over a square minus y square. You may use. So this is the equation of velocity in terms of omega. This is the equation of velocity in terms of y. Copy it fast. Please copy it down. Copy the equations of velocity in terms of omega t as well as in terms of velocity. Yes. Okay. 25 it is. Leah Varshini, I hope you are there in the class.
Yes, sir.
Forgot the rule of owning the video? Written? Fast, fast, fast. So all these things, why we did, Abhinand, you understood? Because I want to get the equation of velocity in terms of y. Shall I proceed with your permission? So, please pay attention, everybody who is there in the online also, pay attention. Nitish, video must be on. So, at extreme, now I can write, wherever I will write extreme, no, I will write y is equal to plus or minus a, isn't it? That is the point of extreme. And wherever I write mean, I will write mean as, I am writing it here by the way, at mean, y will be always 0, isn't it? Because we know displacement is 0 at the mean position and displacement is plus or minus a at the extreme position. Okay, we will put in this equation, velocity equation. So velocity will become equal to what, you see? Yes, a square minus a square, 0. So velocity will become 0. It means velocity is 0 at the extreme position. And what is the velocity at mean position if you put y is equal to 0? Velocity will become equal to omega into a. I should write plus or minus omega into a to be very exact. Because root over a square will become plus or minus a. Tell me, Abhinand. Yes.
Mean position will be the maximum
Velocity,
velocity.
yes, it will be maximum.
So that understanding.
Yes, I can definitely. See from here itself, it is clearly understood, no? At extreme, the pendulum will be having 0 velocity. It is 0 only, velocity is 0. At mean, the velocity will be maximum, plus or minus omega a. Right? If somebody would have used for finding at extreme as omega t, they can use that also. Because what at extreme, what is the value of omega t? Pi by 2 or 3 pi by 2. So pi by 2, put here cos pi by 2. What is cos pi by 2? Cos 90 is how much?
Cos 90 is 0.
0. So what will be velocity?
0.
0. At mean position, what is the value of omega t? Omega t is 0.
It's either cos 0 or
Cos 0,
minus 1 or plus 1.
minus 1 or plus 1. So omega t is 0 or omega t is 180. You will get velocity as plus or minus a omega or omega a, whatever you want to write. So somebody is trying to get extreme or mean by omega t, they can get. Somebody is trying to get extreme or mean by y, they can get. That is the reason I am finding the equation of velocity in terms of omega also, in terms of y also. Because in future you want to use it for in terms of omega, you can use this equation. In terms of y, you will use this equation. Both will lead to same answer. It won't change the answer. Hope you're understanding. Ask me, Abhinand.
Sir, your y is equal to plus or minus a, sir.
Omega a.
Omega a.
Hmm.
No, y, sir.
Oh, extreme, हाँ, tell me, हाँ.
So y is equal to plus or minus omega a, sir.
Hmm.
So let's say it's minus a.
Hmm.
So we put it in this formula.
Minus a square is how much?
Okay, square, okay.
Square is always positive, you know. So it will become once again a square. It will become 0. Understood, Abhinand? Sure? Everybody in the online, any doubt is there? Ask me. I hope everybody is understanding whatever I am telling. Pavitra, Hemant, Kavya, understanding? Any doubt, feel free to raise your hand and ask me. I am always ready to answer you. Okay? Whenever you have any doubt, any point of time, don't hesitate to pause and ask me. Okay? Shall I proceed further? See, here I am not writing in the PPT. Whatever if I erase, it will get erased fully. You are writing properly, no? Okay. Okay. Today you want the class to get over at 9:15 only, no? Okay, let us see. Shall I proceed further? Man, you can write by yourself. What is there in this? Yeah. If you need my help, I'll help you. Next is what? Equation of acceleration. Displacement we found, velocity we found. Now we are going to find the equation of acceleration. Why not? Very simple. Why very simple? Because already we have equation of velocity. Differentiate velocity, what do you get? Acceleration, isn't it? So what is the y equation? Y equation is a sine omega t. What is the velocity equation? What is the velocity equation? Fast, fast, fast. Omega root over a square minus y square, or one more equation is there. Velocity is equal to a omega cos omega t. Do you agree with me? Both equations are there. You can use anyone, whichever you want to use. Nah. Oh, you are saying the answer. Okay, let us see. So we can write the value of acceleration. Since I am using this is omega. Okay, don't confuse. Yeah, I am using capital A. I'll use small a here. So acceleration a will become equal to dv by dt. Do you agree with me? If I differentiate velocity, what I will get? You see, a omega already there. If you differentiate cos omega t, it becomes minus sine omega t, and omega will come, so it will become square, isn't it? Please pay attention. Need not to mug up anything. It's very simple derivation. It comes in exam. I'm saying again and again. So acceleration equation become equal to minus a omega square sine omega t. Anybody has any doubt on this? What chain rule? Chain rule we have used. Cos omega t minus sin omega t is omega. That's what we have used. And it can also be done as, I know that a sin omega t is y. So I can write minus omega square y. Can I write? Yes. This is equation in terms of what? Omega t. And this is the equation in terms of y. In terms of y. Understood? Once again, please pay attention. If I want to write what is at extreme and what is at mean, so I'll write at mean. What is at mean position? Y is equal to plus or minus a, isn't it? So at plus or minus a, if I put the value here, so a will become what? Okay, at mean, right? Y is equal to 0. So I can write extreme. First I am writing extreme, then I am writing mean. Okay. So at extreme, y is equal to plus or minus a. Put plus or minus a there, what will happen? At y plus minus a, it will become a is equal to minus or plus omega square a, isn't it? Why I am writing minus or plus? Because when you put here plus a, it will become minus omega square y. When you put minus a, it will become plus omega square y. So I am writing minus plus, both are same only actually. What about mean position? At mean, y will become 0, a will also become 0. It is exactly opposite to velocity. Velocity was maximum in the mean. Acceleration is 0 at the mean. Velocity was 0 at the extreme. Acceleration is 0 at maximum at the extreme. I hope you are understanding what is happening. Is it clear to you? We'll talk about it.
Can you repeat?
I'll repeat once. I said that if you check your previous page where I derived velocity equation, in velocity we got at mean position velocity is plus or minus omega a, right U1? I think U1 only asked me, no? Yeah. And at the extreme position we got the value of y velocity as 0, right?
Yes, sir.
In this derivation, at mean we are getting 0, extreme we are getting plus or minus omega square a. It means wherever the velocity is 0, acceleration is maximum. Wherever acceleration is maximum, velocity is 0. Are you getting my point?
Yes, sir.
That's what I told, nothing else. If you have understood it, please copy it fast. If you have understood, please copy fast. We have derived velocity displacement equation, we have derived velocity equation, now we have derived acceleration equation also. Displacement is y is equal to a sin omega t. At mean, displacement is 0. At extreme, displacement is plus or minus a. Velocity is omega into root over a square minus y square. At extreme, velocity is 0. At mean, velocity is plus or minus omega a. Acceleration equation is minus omega square y. At mean, acceleration is 0. At extreme, acceleration is plus or minus omega square a. Up to here, if things are clear, I will write some important thing about this acceleration equation. Shall I write that? Guys, can I proceed? Shall I? Okay.
Yes, sir.
Thank you. So, okay, I am not going to erase it. Please pay attention. Please pay attention. So, see here, acceleration is negative omega square y, isn't it? It means acceleration is proportional to minus y. What I said you, for oscillatory motion to be simple harmonic, there are three conditions. First condition was harmonic function satisfied. Second condition was acceleration must be proportional to displacement satisfied. Third condition was acceleration must have opposite direction of displacement satisfied. It means what we are learning now is a simple harmonic motion justified because it is following all the three rules of SHM. Get up, Abhinand?
Yeah.
Understood?
Yeah, understood.
Sure? I hope it is very clear to you. Another important thing, please pay attention. So, I can write from here that the magnitude of acceleration, magnitude I am writing, so omega square y I am taking, only the magnitude. Okay? From here I can write omega is equal to root of acceleration by velocity. Anybody has any doubt in this? Before some time I told you, not velocity, displacement, sorry. Before some time I told you omega is equal to 2 pi by t, isn't it? So, 2 pi by t is equal to root of a by y. If 2 pi by t is equal to root of a by y, can I write that t is equal to 2 pi root over y by a? In many places you will use this. Time period of simple harmonic motion is 2 pi root over displacement by acceleration. Remember this forever, at least till you finish your NEET or JEE examination. Very important thing. I am stressing and saying this is a very important equation. What equation? Time period as 2 pi root over y by a. That is time period of any simple harmonic motion. Time period of any simple harmonic motion will be always equal to 2 pi root over displacement by acceleration. Keep this in your head. Even for simple pendulum, we have got 2 pi root over L by G, no? Comes from here only. I'll show you how. Clear up to here? Any doubt in this? Any doubt in this?
No, sir.
I think that student who's trying to join is Sanjeet. His mother name is only Kausalya, I think. Shall I proceed further?
Yes, sir.
Again, if I proceed, I'll erase the board. If I erase the board, we cannot retrieve it.
Yeah, sir, you can write it.
Write it, no? Shall I proceed? I hope everybody agrees. What, Varshika? Write by yourself if you have not written. What is there in big thing? If you are understanding, you can write. I don't believe on copying from the board. Coming back. So now we got displacement, we got velocity, we got acceleration. Next we will go to energy, shall we? Shall we go to energy graph? Graph means energy equation first, then we will go to graph. So I hope you understand that in any simple harmonic motion, energy is getting stored. This we have done in our work energy and power chapter itself. You remember? Kinetic energy, potential energy. What, Mr. Sugendran?
At a finding spring,
Yes, yes, very good. F is equal to minus kx, and from then finding u is equal to minus half kx square. You remember? These things we have done in the work energy and power chapter itself. Once again, it will repeat here. I'll repeat. I'll not say as we learned. We'll repeat here. Don't worry. So let us try to find what is the equation of energy in simple harmonic motion. Whenever I use the word energy, I will have to find both energies, kinetic energy and potential energy. How we can find kinetic energy? It's very simple, because kinetic energy is half mv square and equation of velocity is known to us. What is velocity equation? A omega cos omega t. Remember? If you put that value here, then kinetic energy will become equal to half into m into a square omega square cos square omega t. Clear? Clear? Also, I told you velocity is equal to, what equation we got that time? Omega into root over a square minus y square. Do you remember this equation in terms of displacement? So if I want to find kinetic energy in terms of displacement, I will write half into m into v square is omega square into a square minus y square. Is it clear to you? This is the equation of kinetic energy in terms of what? Very good. And this is the equation of in terms of displacement. I hope you are understanding. See, everything is going very simple. If you are understanding, damn simple thing, 5 marks easily you can score if the question comes in the examination. Kinetic energy is clear to you? Copy it fast, then I'll talk about potential energy. Fast, fast, fast. I think we can write even the values of maximum and minimum, because kinetic energy at mean position. Question I gave. Okay, that we will discuss, man. We are in this class suddenly talking about mango. Okay, we are talking about grocery or talking about fruits. Okay, coming back. At mean position. At mean position, what is y? Y is equal to 0, isn't it? Put y is equal to 0 here. How much is the kinetic energy you are going to get? Half m omega square a square. At extreme, what you are going to get? At extreme, what is the value of y? Y is equal to plus or minus A. Put plus or minus A here, kinetic energy will be 0. Common sense. At extreme position, velocity is not there. If velocity is not there, where is the question of kinetic energy? Kinetic energy is going to be 0 only at the extreme position, and kinetic energy is going to be maximum at the mean position, and its value is half m omega square A square. Any gentleman has doubt, or gentlewoman, anybody is having any doubt? Actually we should say ladies and gentlemen, right? Sorry. It is going live also. Okay. Fine. So is it clear? Any doubt you can ask me. If there is no doubt, I will go for potential energy. Clear? Because potential energy is little complex, not much complex. Huh? Half kx square. That is elastic potential energy, Tanvi. So you should not use that. I should not find in terms of spring constant. I should find in terms of this only. We'll do it. Shall I do it? Shall I? Okay. So what we will do now, we will find the potential energy with the help of work done. I hope you remember that work done is integral of f dot dx, in this case dy, because we are taking displacement in y direction. So I have to find the value of force, and I have to use integral f dy and integrate, we will get the answer of work done. That work done will be stored as potential energy. Is it clear to you how we are going to find potential energy? We are going to use the help of work done. Work done is integration of f dx or f dy. Displacement is the matter. So in this case we are taking displacement in y direction, so we are taking integral of f dy. How to find the value of f? We know that f is equal to mass into acceleration. Acceleration's magnitude was how much in the previous thing? It was minus omega square y, but its magnitude is how much? Omega square y, isn't it? I am going to use that. So what will be the work done? That is the potential energy stored. It will be equal to integral of omega square y dy. Do you agree with me? M also is there, no? What I wrote here? Yeah, m is there. Yeah, m I will take it outside, constant. Can I? So what is the potential energy going to be? Potential energy is going to be m omega square into y square by 2. Do you agree with me? Do you agree? And if I put the value of y as, what is the equation of y? Y is equal to, what is this? A sine omega t, isn't it? Y is equal to A sine omega t. If I use this here, then I am going to get potential energy as half m omega square. Instead of y square I will write A square sine square omega t. This is the equation of potential energy. Yes, it is in terms of omega t. In terms of omega t. This is the equation of potential energy in terms of y. Are you understanding this? Half m omega square y square in terms of y, and half m omega square a square sine square omega t in terms of omega t. We will check now. Yes, obviously it will be 0. Conservation of energy, no. At mean, what is 0? Y is 0. So if y is 0, put here y is 0, you will get potential energy also as 0. And at extreme position, what is y? Plus or minus a. Y is equal to plus or minus a. If you put plus or minus a, what are you going to get? Yes, half m omega square a square is the potential energy at extreme. Do you understand it? I hope things are clear up to here. What is the equation of kinetic energy? What is the equation of potential energy in terms of displacement, in terms of omega t? Everything should be clear by now. If you are listening the class properly, everything should be clear by now. Don't get confused if your school would have taken x is equal to a cos omega t and derived all these things. The steps remains the same. Today the homework is that only. Today's homework is you will go and do the same thing in terms of x is equal to a cos omega t. Everything will remain same. Just check what changes. I am serious on this. I will check the homework in tomorrow's class in Perambalur and on Friday in SSM Nagar. What is the tomorrow after writing exam when you come, before coming 15 minutes solve and come. It will take 15 minutes only, man, for doing. Now I am teaching, so it is taking time. If you do by yourself, it will take less time only. Don't do it tonight, do it tomorrow. Okay. Have you copied it? Shall I proceed further? Okay. 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 So you have understood that kinetic energy is half m omega square a square minus y square. Potential energy is half m omega square y square. What will be the total energy? Potential energy plus kinetic energy. What will be that? Half m omega square into a square. Do you agree with me? And you can see total energy is, because it is irrespective of y, there is no y term in that. So there is no y term in that. It means whether it is extreme position, mean position or random position, always total energy will remain half m omega square a square, which proves the conservation of energy also. At extreme position, kinetic energy is 0, potential energy half m omega square a square, total energy will be half m omega square a square. At mean position, kinetic energy half m omega square a square, potential energy 0. Add both, total energy will become half m omega square a square. Whether it is extreme, whether it is mean, whether it is random, always the total energy will be half m omega square a square. Is it clear to you? Sure? Can I erase the board? Because to go to the next page I have to erase the board, and if I erase the board I cannot once again bring it back. Shall I? There, Yuvan, Shweta Shinde, shall I?
Yes, sir.
Yes, sir.
Okay, thank you. So, after doing all these, now it is the time of graph. Again, a very important part of this chapter, the graphs. All the graph of displacement, velocity, acceleration, kinetic energy, potential energy, total energy, everything together. So before drawing the graph, I must write all the equations on one side. Here I will write all the equations. Okay? Please help me. Y is equal to a sine omega t. Velocity equal to, or I will change the color and write, oh shit. Okay. Velocity is equal to omega into root over a square minus y square, or I can write velocity equal to a omega cos omega t, isn't it? So this is the equation of velocity. Now the equation of acceleration. So acceleration is equal to minus omega square, obviously y, and what is the another equation?
Minus omega square. Yeah, minus omega square. Then we'll substitute y a sin omega t.
Minus a omega square sine omega t. Good, man. I am not saying you are wrong. When I say you are wrong, you cannot be wrong. Yes. Next is kinetic energy, potential energy, total energy. So what is the value of, yes, kinetic energy? Kinetic energy is half m omega square y square. Don't write, oh, a square minus y square. A square minus y square, and if I write in terms of potential energy, I will not write that. What is that? Half m omega square y square, and what is total energy? Half m omega square y square. Clear? Okay, just recalling all the formula whatever we learned in today's class. Now drawing a graph. So, very calmly, patiently, I will draw all these 6 graphs. It takes time. So, I will divide everything into all the extreme ending position. First, the time point is omega t is 0, then omega t becomes 90 degree. Okay. Here I am writing omega t as pi by 2. Okay. Then I am writing omega t as how much? After pi by 2 it will become pi, no? Pi. Then what it will become? Omega t as 3 pi by 2. Then I will write omega t as 2 pi. Let us stop here, no? This much is enough. I should have given some more space. Okay. Now what I am going to do? I am going to draw some lines, because I am going to draw many graphs. So, I will take some reference. It will be easy for us to draw. Okay. Now, first let us draw the graph of what? Displacement graph we will draw, then we will draw velocity graph, then we will draw acceleration graph. I will draw in same kinetic energy, potential energy, total energy, in one graph I will draw. Space is not there. Okay. This point is omega t is 0. Okay. Now, let me use a different color. Yes. Shall I? Please help me now. So, for displacement at the mean position, what is the displacement? 0. At extreme, plus a. Then once again, 0. And once again, minus a. And once again 0, right? Came sine graph, it should come. Next, this was the equation of what? Displacement. Next is the equation of velocity. Velocity is what at the mean position?
0.
Very good.
Oh, maximum will be 1.
Blabber something. The value of velocity and at the mean will be how much here? Y is equal to 0, it will be plus or minus omega a, isn't it? So, plus omega a. This point also you write, like here the point is plus a, isn't it? Here it was minus a. Same way here I will write it as plus omega a, not a. What is this one? Then 0, then minus omega a, then 0, then plus omega a. Are you understanding? This is the graph of velocity. Then comes the graph of acceleration. Acceleration at mean is how much? 0. So, I will take 0. Then it is how much? Minus omega square a will come first. So, minus omega square a, then 0, then plus omega square a, then 0. If I draw this, it will come like this. Exactly opposite of displacement. It is ulta of displacement, am I right? Okay. This then comes the energy. I will write kinetic energy also, potential energy also, and total energy also. I will take 3 different colors. So, I will choose color 3 only I have. I will use red for total energy. Yeah, this blue and all will be visible. Let us try. So, first I will use blue. Blue for the kinetic energy. Kinetic energy, what is the value? At extreme, at mean. Maximum. What is that? Not 1, half m omega square a square. So, there is the value. Its value is half m omega square a square. Then it will become 0. Then it will become negative. Hey. Omega t is pi, isn't it? Or y is equal to, how it will become negative, man?
Oh, it can't become negative.
Can never become negative. Y is equal to, you are putting plus a or minus a, it will be 0. Yes, so it will become once again like this, once again 0, once again like this, isn't it? How the graph came? The graph came like this. Do you agree? If anybody is getting any doubt, feel free to ask me. Yes, it will be like that, because once again it will be half m omega. Huh? Yes, we had the same we had. And finally total energy. Total energy will be a straight line joining all these points, which is always half m omega square a square. They will say frequency of energy graph is double the frequency of displacement graph. Yes, obviously. See here, how many you got? 1, 2. Here you got only 1. Isn't it? And energy graph has no negative values. Yes, very true. Always positive. Whereas displacement, velocity, acceleration have both positive and negative points. Energy will never be negative. Sanjeet, you are seeing some other video? Or talking to your brother, mother, father, somebody?
No, sir. Two devices was connected, sir.
Oh,
One device got.
Okay, so you are having one device for seeing me, one device for seeing something else.
No, sir.
Okay.
Without knowing computer got stolen, sir.
Okay, whatever, man. Copy it fast. Finish copying, finish copying, finish copying. Draw the graphs. Important.
Sir,
Yes, man.
sir, I don't understand with the acceleration graph, sir.
Okay, I'll tell you. So, acceleration equation is clear to you, Manoranjan? Please be unmuted for some 1 minute. Unmute yourself for 1 minute. Manoranjan.
Yes, sir.
Yes. So, this equation is clear to you?
Yes, sir.
Okay. If we start, or let us take this equation for instance for helping you. So, minus a omega square sin omega t. First point is omega t as 0, right, Manoranjan?
Yes, sir.
When you put sin omega t as omega t 0, how much will be acceleration? When omega t is 0, what is sin omega t?
Sin omega is 0, sir.
Obviously 0, sin 0 0. So, a will become 0, right?
Yes, sir.
I plotted a is equal to 0 here. Okay. Then, what is the second point? Second point is omega t as pi by 2, right, Manoranjan?
Yes, sir.
I put pi by 2 here. What is sin pi by 2?
1.
1. So, it will be minus a omega square, right, Mr. Manoranjan?
Okay, sir.
Understood? It became minus omega
Yes,
square.
sir, understand.
Now, shall I tell further points or you have understood?
Understood, sir.
Okay, good. Anshul?
Thank you, sir.
Yes, okay. Anshul, understood or not?
Yes, sir. Yes, sir. Yes, sir.
Sure.
Yes, sir.
Okay, anybody? Who is that? Can I proceed further with your permission? No. Sure, you told.
Yes, sir.
Okay, I hope you have copied the graph. Don't worry, you can do by yourself, or I am going to share the video link. You can see from there and copy later. Okay. I am proceeding further. Shall I? Okay. So, yes, my boy. Numerical. Next question is very simple question. Can you find? They gave the mass, they gave the amplitude, they gave the time period. They are asking you to find the total mechanical energy of the system. Very simple question. Total energy formula you know, half m omega square a square. That's all. Everything they gave. M they gave. Omega you can find by time period. 2 pi by omega is t. I told the answer itself. Fast, fast, fast. Do it. Just you should multiply and get the answer. Everything is in CGS units. You can get the answer in CGS unit and tell the answer in terms of ergs. Obviously, because everything is in CGS unit. Mass is in grams, amplitude is in centimeter, and time is in seconds. CGS. Fast, fast, fast. Solve it, solve it, solve it. Pi value. What you put, man? 3.14 or 22 by 7, whatever suits you put. They have done in joules. You can do in ergs also, no problem in that. 80? 80 pi ergs,
Yeah.
maybe. What is the conversion of ergs to joule? Any remembrance?
That's joule.
Hmm.
10 to the power 5, right?
Minus 4, I think. Minus 10.
No, not 1. I'm saying 1 joule is equal to 10 to the power 5.
10 to the power 5 or 4? 5.
I don't know.
If you can convert it, if you want to convert, what is there in that? So this is the answer in terms of joules. You can report the answer in ergs also, no problem in that. If you want, I'll solve it parallelly. So half into m is 40 into omega is
Omega is 2 pi by t.
2 pi by t. So 2 pi square, it will become 4 pi square by time period is 0.2 multiplied by a square. A square will become 4, isn't it? So 0.2, well, 1 0 will come, and this 2 and 2 is 4, it will cancel this. So I am going to have 1600 pi square ergs. What you told, man?
No, I saw it. Don't be there. 900 square the omega.
Total energy is this much. Okay?
Omega square 100.
Got it? Simple question. If you want, you can solve further also. It's not a big deal. It's simple, very basic question. I hope nobody has doubt in this. Everything is given. What doubt you will get? Okay. So this topic is the next topic which we are going to take in the next class. Thank you for bearing with me up to 9 o'clock. We will meet again on next class. Next class, very small topic is remaining. Spring and pendulum, both are half an hour topic only. After that, we will start talking about waves. Since we started oscillation, let us finish waves and then come back to thermodynamics and KTG. Okay. So, anything you want to ask, online children? Anything you want to ask, please feel free to ask me. If nothing is there to ask, then take care. Go and have your dinner and sleep. If you not had in between the class. So take care. Bye bye. We will meet again in the next class.